All right. So when you log into Canvas, so today's lesson is on molar mass. So we kind of talked about this in the lesson from Wednesday, because we talked about that mole concept and the fact that um, we know that 1 mole in chemistry equals Avogadro's number of particles. So 1 mole always equals 6.02 times 10 to the 23rd, either atoms or molecules or formula units. Okay. But we also talked about the fact that masses are not going to be the same because our different atoms, they have different sizes. And so today we're going to talk about how do we calculate molar mass for things that are not elements. Because last time we looked and we said, well, if I look at hydrogen here on the periodic table, its atomic mass is 1.01 units. So its molar mass is 1.01 grams. Okay, if I just have one atom of hydrogen or 1 mole of hydrogen, excuse me. If I wanted to do, boron, 1 mole of boron would have a mass of 10.81 grams because that's what its atomic mass is on the periodic table. But we are going to talk about today about, well, what does that mean for a compound? If I don't have something that's just a single element, then how do I figure out the molar mass? So when you look at your lesson, it just kind of recaps what I said about, we remember that 1 mole is always the same number of particles from Avogadro's number from our lesson on Wednesday. But having the same number of particles does not mean that 1 mole of anything will have the same mass or even the same volume. We're not going to deal with volume in this unit, but when we do a couple units from now, we're going to start talking about gases. And so when we get to gases, we also add in volumes for gases. Okay. So this picture over here, all of these substances, this is all 1 mole of these substances. So this is a compound, mercury 2 oxides, kind of this reddish orange color. Sucrose, this is just table sugar, like you would have in your pantry at home to cook and bake with. Sulfur, so this is an element. Copper 2 sulfate pentahydrate. This is a special kind of compound. It's an ionic compound that has water molecules attached. So that's why it's got this second part of the name, the pentahydrate. This is just the element copper. This one here, this is table salt, sodium chloride, like in your salt shaker at home. And then here is just water. So this is a mole of water. Okay. And so you can see, even though I'm telling you all of these are 1 mole, they're definitely not, it doesn't look like they're the same to our eye because their masses are different. Okay. But all of these do contain 6.02 times 10 to the 23rd particles of that substance. It's just that, something like copper, an element, that those are only atoms. And so they're pretty small compared to something like sucrose, that's sugar. That's its chemical formula is C12H22O11. So there's a lot of atoms in one molecule of that. And so obviously they're going to take up more space. They're going to weigh more and have more mass because of that. And so these are some different elements. Okay. So these are all, this is zinc, carbon, magnesium, copper, sulfur, silicon, lead, and tin. So all these are elements from the periodic table. And all of these are showing you 1 mole of those substances, but we can see that they have different masses, okay? Because if I put them on a balance, on a scale, their masses are different, but they all contain the same number of particles. So 1 mole always equals Avogadro's number of particles, but the mass of that 1 mole is going to change depending on what our substance is, okay? And so that kind of leads us into the differences. So we talked last time about elements. All you do is look on the periodic table. And if it's a diatomic element, though, if it's written like this, okay, now if they just say hydrogen with a single H, then that's just, 1.01. But if they say it's hydrogen gas and they give you this formula H2, then you have to double it. You have to multiply it by the subscript. So if you're given any of these diatomic elements with their formula written like this with the 2 subscript, you have to double it. Their molar mass is going to be multiplied by 2 from whatever you get from the periodic table. Okay. And then this is just kind of a cool little video because this has the element gallium, which has a very, very low melting point. In fact, you put it in a cup of warm water and the whole thing just melts and becomes liquid. So that's related because this question's asking you about gallium and its molar mass. Okay. So you have some practice questions down here with some different elements. Some of them are single, some of them are diatomic, some of them are something else. So you can practice checking to see if you understand how to calculate those molar masses. When you go to the next page, now it's going to talk about molar masses of a compound. So if you have a compound, obviously that's going to be multiple elements, and sometimes they're going to have subscripts and different things like that. So you have to add together, or you have to sum the molar masses of all the atoms in the formula. Okay, so there's a sample calculation here. It's pretty straightforward to follow. So we're going to go through it, and then when we're done, I'm going to go through another one with you guys on the iPad. We're going to kind of work it out together using our periodic table. So the first thing you always want to do is list the elements. So you need the chemical formula. If they give you the chemical formula, it's really easy. I can just look and I can say, okay, there's Na, which is sodium, there's C, which is carbon, and there's O, which is oxygen. If they don't give me the formula, if they just tell me the name, that's a little harder, because if they give you the name, you're going to have to write the formula first before you can do this. So this is where we go back to unit 4, where we learned how to write the names and formulas, because if they give you the chemical name, they're expecting that you can write the formula and then use the formula to do this process to calculate the molar mass. So if you still are having trouble with writing the formulas, then questions like that are a little more challenging are going to be difficult for you. Okay, so we list out our elements, okay, any elements that are in the compound. Then I want to look on my periodic table. I need to look for the atomic mass of each element from the periodic table. The one that you have for the lesson that's up here, all of these are rounded to 2 decimal places. The one that you have here on the reference chart, they're also rounded to 2 decimal places. So you can use this one on the page, or if you want to go to the reference chart. The only thing I will point out is for today's lesson on this one that's on here, sulfur is rounded to 32.06. But on our reference chart, it's 32.07 because it's actually really close. And so some periodic tables round it to 06, some round it to 07. So for if there's questions with sulfur in today's lesson, make sure you're using this one. But in the future, you can use the reference chart. It doesn't really matter. But I generally tell people to use 2 decimal places for molar masses. And so that's why we're using this one or the reference chart, because they are already rounded to 2 decimal places. Okay. So you're not going to round them off any more than they already are. So if we look up here, here is sodium Na, and I can see right here it's 22.99. So all I'm doing is copying that from the periodic table. Carbon C is 12.01, and then oxygen is 16 even, is 16.00. Okay. So I just copied those numbers down. I didn't round anything off. Then I want to look for multipliers in the formula. So multipliers are going to come from your subscripts. Okay. So if we look at this formula, where'd it go? Na2CO3, there's a subscript behind sodium, and there's a subscript behind oxygen. So that means that they are going to be multiplied. So I'm going to take sodium's molar mass from the periodic table, and it's going to get multiplied by 2 because sodium had a 2 subscript, and that 2 subscript means there are 2 atoms of sodium in that formula. So I have to double the mass because there's twice as much sodium. Carbon, I don't need to multiply it by anything because there's only 1 carbon. There's no subscript right after the C. But then after the oxygen, there's a 3. So the oxygen's molar mass from the periodic table gets multiplied by 3. So I'm going to multiply any of them that have subscripts by the whatever the number is for the subscript. It does say here, be careful if you have parentheses, because if you have parentheses, like the next example we're going to look at, that does your numbers have to distribute just like in math. Okay. And so then once you multiply, you will multiply and add them together. You can do it in multiple steps. Like if you want to multiply and get all the answers and then add all of them up separately, you can do it in 2 steps. Or if you like to do everything in your calculator at once, you can put everything in parentheses. You just have to make sure you put parentheses around the multiplication so that it does the right order of operation. So for this one, 22.99 times 2 plus 12.01 plus 16 times 3. And when we add all of that up, we get 105.99. Okay. Another example, this has got aluminum sulfate. So this one's got parentheses. So that's why we're looking at an example that has parentheses, because they're a little bit more challenging. This is used in gardening. So it's helps lower the soil pH because some plants grow better in acidic soil, some grow better in basic soil. So if you adjust the soil pH, sometimes they grow better, or sometimes they turn different colors. Like I have a hydrangea bush at the front of my house, and some years it blooms and it's more of a bluish purple color. Some years it blooms and it's more pink. And it just depends on like the pH of the soil, because it turns different colors depending on that. So aluminum sulfate, you can use it to make your soil more acidic. So plants that like acids can grow better or grow different colors. So if we look here, here's the formula. So all I did was I broke it down. I looked up on the periodic table, aluminum's molar mass was 26.98, sulfur's 32.06, oxygen 16.00. And then if I look, there is a subscript 2 right behind aluminum, so that's why it gets multiplied by 2. Sulfur, now there's not anything right behind the sulfur, so that's, an imaginary 1, but it's in parentheses and there's a 3 outside. So that 3, just like in math, anytime you have like a number outside parentheses, it distributes and it multiplies by everything inside the parentheses. So the 3 is going to multiply by the sulfur, so that's why it's getting multiplied by 3. But the 3 is also going to multiply by the oxygen because that's inside the parentheses as well. So the oxygen is multiplied by 4 because it has a 4 right behind it, but then it's also multiplied by 3 because that 3 is outside the parentheses. So it gets multiplied by 4 and 3, or you could just say it gets multiplied by 12. Okay, you can write it either way. So in your calculator, aluminum times 2 plus sulfur times 3 plus oxygen times 12, and this is what you should get for the total. Okay, so obviously this is a way different number than we got for the first one. The first one, 105.99. This one, 342.14. So this one has a much higher molar mass. And it makes sense because look how many atoms are in it. There's 12 oxygens, 3 sulfurs, and 2 aluminums. There's, what is that, 12, 13, 14, there's 17 different atoms in this one. Whereas in this one, we had 2, 3, 4, 5, 6. We only had 6 atoms in this one. Okay. And so if you have more atoms, typically that's going to mean a higher molar mass. And also if you have larger atoms, like, look at sodium's mass, it's almost 23. But then look at here, like sulfur's 32, aluminum is almost 27. So you have larger atoms, and if you have more atoms, that's going to make your molar mass for a compound be larger. Okay. So you have some practice ones down here where it's going to ask you questions like, what should a certain thing be multiplied by, or maybe what is the molar mass of something. So you'll be kind of using the techniques that we just looked at for how to figure out those questions. The last section before we do a couple examples together is a specific kind of compound. They're called hydrates. And hydrates are molecules that they have trapped a certain number of water molecules in their structure. And so that changes their molar mass, because if they've trapped water molecules, that means there's some hydrogen and oxygen that are adding on to the molar mass. So this is an example. This is cobalt 2 chloride. And so if it's anhydrous, which means that it doesn't have any water in it, then it's this kind of blue color, blue powdery color. If it has the water molecules attached, then it looks like this. It's cobalt 2 chloride, and then this is hexahydrate. Hexa means there's 6 water molecules attached. So we use the same prefixes that we do for like our covalent compounds. And so now look, it's kind of this reddish purpley color, okay? And that changed the color, and that also changes the molar mass because now there's 6 water molecules attached to this cobalt 2 chloride. And so what you do for that is you calculate the molar mass of your compound, just like we saw on the last slide. And then what you have to do is you have to do the molar mass for water and then multiply it by whatever the coefficient in front of the water is. Okay. So some other examples, there's barium chloride dihydrate, iron 2 sulfate hexahydrate, sodium carbonate decahydrate, copper 2 sulfate pentahydrate. And so all of them, you see the prefix matches whatever number is in front of the water. So to calculate the molar mass for something like this, you calculate the molar mass of that formula, just like we saw on the last section without the water. And then you add the molar mass of water, which the molar mass of water is 18.02 grams. Because it has 2 hydrogens, that's 2.02, and then 1 oxygen is 16. So total for water, it's always 18.02. And you multiply it by the coefficient. So if we do barium chloride dihydrate, this first one from up here as an example, here's barium from the periodic table, here's chlorine from the periodic table, and it's multiplied by 2 because there is a 2 subscript on the Cl in the formula. So that's the compound. And then here's my water molecule, which water is 18.02, and I'm multiplying it by 2 because of the 2 coefficient in front of the water. And so then I would add all of that together, and here is what I would get for my total. So similar process, it's just you're also having to include the water molecules if it's a formula like this where it has a hydrate in it. Okay. All right, so I am going to switch over to the iPad, and we're going to do a couple together. And I'm going to kind of ask you guys. So if you are able, well, I'll have the periodic table on my screen, so you don't have to have it open. So, all right. So I am going to write a formula, and you guys are going to guide me through how we would calculate its molar mass. So let's see. I'm going to do, let's do, okay. So K3PO4, this is potassium phosphate. So this is my formula. So what is the first thing that I want to do with this formula to start my process of doing the molar mass? What's the first thing that I should like write down or do for my setup?
List the elements and compound.
Yeah, so I'm going to make a list. So I just do them usually in order of the formula. So we have potassium, that's K. We have phosphorus, P, and we have oxygen, O. So I'm going to list all my elements. So there's 3 elements in this one. Sometimes there'll be 2 or 4. It just kind of depends. Now, next thing is I want to look up their molar masses for each of these elements from the periodic table. So I'm going to scroll up here because I have our formula chart on here that we can refer to. So let's let it scroll up. Okay, so I'm looking for K. I'm looking for potassium. So let it, oh, there it goes. I was going to say it's going to clear up a little bit and not be blurry. There we go. Okay, so can anybody find potassium? K?
The first row.
Yep, it's over here. It's in the first group, group number 1. And its molar mass, if I look on the key up here, right here, AMU, that's the atomic mass units. That's the atomic mass. So that's the number we use for the molar mass. So for potassium, it is 39.10. What about for phosphorus? Anybody find P? Where's P at?
I'm at 15.
Yes, thank you. It's in group 15 over here. Here's phosphorus, and its molar mass is 30.97. And then finally, I need oxygen, which oxygen, right, kind of close to phosphorus, is over here in group 16. And we already know from the examples we saw in the notes that oxygen is 16. I will tell you there are some elements that you're probably, if you do enough practice, you're going to memorize, like hydrogen, carbon, nitrogen, oxygen. They show up in a lot of compounds, so their molar masses, like you should be able to kind of recall them from memory once we've done enough practice because they show up a lot of different times. Okay. Okay, so I have 39.10, 30.97, and 16. So I'm going to go back down here and we're going to write those down. So we have 39.10, 30.97, and 16.00. So now the next thing would be to multiply them by their subscripts. So if I scroll back up to the formula here, what do we multiply K by?
3.
3. Okay, there's a 3 subscript right behind the K. So it gets multiplied by 3. What about the phosphorus, the P?
1.
Yeah, so you can either leave it alone, or if you want to fill it in, you can put times 1, but you don't really need to multiply that. Or like in the notes, you can just leave it alone. If it's a 1, you don't have to show that you're multiplying by 1. And then what about the oxygen on this one, the O? 4. Thank you, AJ. So now this is where you would, at this point, you would need a calculator. Okay. because we would need to multiply these. The phosphorus is pretty easy. Obviously, it's going to stay the same. So I can go ahead and write that one, 30.97. I've done enough of these problems over the years that I can, you know how like in elementary school and you learn like, 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10. You learn all those like times tables type of things. Well, I've multiplied oxygen enough times that I can multiply 16 probably up to like 6 or 8 in my head. Because I know 16 times 1 is 16, and then 32, and then 48, and then 16 times 4 is 64, because oxygen shows up in so many compounds that I have basically memorized up to multiplying, by 7 or 8 maybe, or something like that, by 16. But in your calculator, if you do 16 times 4, you will get 64. And then the last one, which I haven't, this one's a little harder because this is not as common. So let's see, 39.10 times 3. And it is 117.30. Uh-oh, what happened? We got cut off. Hold on, guys. All right, so 117.30. And then our last step would then be to add these together. I'm going to clean up this 0 a little bit because I messed it up when the screen stopped sharing. Okay, so then I would add these all together. So 117.30 plus 30.97 plus 64. And for this one, I would get 212.27. Okay, now your units are always grams, okay, because this is a molar mass. But a lot of times you will see that they will write it like this. They will write grams/mole. They will write grams per mole because this is molar mass. So what this means, because this is, remember, this is one of our conversion factors. So what this means is for potassium phosphate, this means 212.27 grams equals 1 mole for this substance. So for other substances, it'll be a different number of grams. But whatever it is, after you calculate it, that many grams always equals 1 mole for that substance, okay? So like, in the notes, when we said like on the hydrate part, how we said, well, water is 18.02 grams. So really what that means that for water, 18.02 grams equals 1 mole for water, for H2O. For other substances, if I did, I don't know, just oxygen gas, like O2. Why are we not writing? Oh, there it goes. So if I did just oxygen, which is O2, that's 16, but I got to multiply it by 2 because of the subscript. So really that's 32 grams equals 1 mole. So whatever substance you have, after you calculate its molar mass, that many grams equals 1 mole, okay? And we also know that 1 mole always equals Avogadro's number of particles. So all of these all equal 6.02 times 10 to the 23rd particles. So for oxygen, well, all of these are going to be water, it would be molecules. This one, it would be molecules. For this one, we just solved for in green. This is an ionic compound. So for this one, this would be formula units, not molecules. But all of them are going to be equal to 6.02 times 10 to the 23rd of whatever type of particle they are, whether it's atoms, molecules, formula units, whatever. So what we're going to start getting into next week is we're going to take these two concepts. We're going to take Avogadro's number being equal to 1 mole, and we're going to take molar mass of substances being equal to 1 mole, and we're going to start to do math with them. We're going to start to do conversions, okay? Like we did with our dimensional analysis, because what we're going to see next week is it's going to be a question like, I have 2.87 times 10 to the 42nd you know, atoms of, I don't know, aluminum, okay? And I want to know how many grams is that. So they might tell me I have 200 or 2.87 times 10 to the 42nd atoms of aluminum. How many grams of aluminum would I need to measure out to have that many atoms? And so what you're going to do is like, this is your known, your grams are your unknown. And so you'll set up a problem where you'll start with 2.87 times 10 to the 42nd atoms of aluminum, and then you'll use dimensional analysis because I know that Avogadro's number, 6.02 times 10 to the 23rd atoms, I know that equals 1 mole, so I can convert it to moles by using Avogadro's number as a conversion factor. And then I can continue and I can say, and 1 mole for aluminum equals whatever its molar mass is on the periodic table, which for aluminum is, I believe it was 26.98. And so we're going to be using that concept of dimensional analysis that we learned about at the beginning of this week. We're going to be combining it with Avogadro's number and molar masses and moles in order to do calculations, because the process works the same way, because atoms cancel out with atoms, mole cancels out with mole. We're left with grams on top, which is what we're solving for, the unknown. And then we just simply multiply and divide. So I would do 2.87 times 10 to the 42nd power divided by Avogadro's number, and then I would multiply by 26.98 to get my answer, okay? And we're going to talk about like how we type these numbers in the calculator in scientific notation and that kind of stuff. So that's what's coming next week, is now that we've learned about kind of Avogadro's number and how that relates to a mole, and molar mass and how to calculate molar mass and how that relates to a mole. Next week, we're going to kind of put it together and start doing conversions and calculations with it, okay? So last thing I just want to go over today is I want to reiterate once again that this is Friday. This is February 5th. Next Friday, February 12th, is the end of the 6 weeks. That means like all work would be due by the end of that day, next Friday, for the 6 weeks. So if you have assignments that are not completed, that you have not submitted, if you haven't done your test from Unit 5 last week, it is still open. So you need to get that done. If you took it, but you want to take it a second time to try to improve your grade, I would definitely advise doing that, because you do have 2 chances, so you can take it and improve your grade. And it won't hurt you if you retake it. Like if you do worse, it's not going to go any lower, but if you do better, then it's going to increase, okay? So definitely, if you haven't taken the test, you need to take it. If you haven't taken it a second time and you want to take it to try to get higher, do that. Some of you guys also haven't done the quiz over the types of reactions from earlier last unit. And then also just your daily assignments. If you have anything missing or you're not, haven't submitted anything, make sure you're getting all of that stuff caught up. That's why today's pretty short, because you do have kind of a short assignment today, but it's just a few practice problems of doing these calculations of molar mass. And it's pretty straightforward, pretty short, because I wanted you guys to have, some time today and maybe over the weekend to get caught up on everything else if you're behind, okay?